All right. Well, hello everyone, and welcome to Hybrid Multi-Cloud Database Management with NDB. My name is Jeremy Lagnier. I'm joined here with my co-presenter David Teague from our engineering team. So we have a great session planned for you today. I'll just give you a quick overview before we dive into it. So the today you'll learn about how NDB can support database workloads in the public cloud, as well as on-prem. We will talk about which types of database engines we can support in the cloud, what types of HA models and DR support we have for those. David has a great demo planned as well. And then, of course, we'll have an open Q&A session for anybody that has any questions for us. So let's just jump right into it. So for those of you not familiar with NDB, I'll just spend a few minutes and kind of provide some highlights of what NDB is, Nutanix Database Service. So the best way to think of it, NDB is a software platform that runs on Nutanix cloud infrastructure. And that platform provides a standard UI, API, CLI to provision and manage the lifecycle of the most popular database engines out there. And so that includes provisioning, scaling of your databases, patching of your databases, point-in-time backup recovery, which is accelerated with snapshotting capabilities from Nutanix, as well as a very powerful capability around database cloning and refreshing of data into those funds. And we'll talk a little bit more about that later. But those all become very, very powerful lifecycle management capabilities for databases that we have traditionally have offered on premises and in the cloud. We also support the most popular database engines. So I'll just name a few. So Oracle database, SQL Server, Microsoft SQL Server, Postgres, MySQL, MongoDB, for sure. On premises, those databases are run on top of two different hypervisor choices, our own AHV-based hypervisor, as well as VMware, Broadcom's ESX hypervisor. We also support those exact same configurations in the cloud on top of what we call Nutanix Cloud Infrastructure, or NC2 clusters. And those are basically bare metal EC2 or Azure compute instances that run in the respective hypervisor clouds. And it's our HCI software stack that runs on top of that physical hardware. And by doing so, we basically end up with a distributed cluster just like you would have on premises that behaves the exact same way. So we support two clouds today. We are working with our partners to add support for Google in the future. So that's something that's kind of on the roadmap. But for time being, you can run your databases with the same experience on-prem in Azure or in AWS. Let me just kind of highlight some of the key sort of unique capabilities that are unique around hybrid, because I think a lot of times customers they run their databases, they pick the location for where they run their databases. They may choose to run it in the cloud because that's close to where their other applications are, or they may be trying to take advantage of certain hardware that's available with the cloud provider, such as GPUs. Or maybe, for example, they are trying to optimize costs in certain regions and whatnot, and so they choose certain locations. But there are also scenarios where it's important to build support data mobility across cloud boundaries from on-premises to the cloud and vice versa. So there are three hybrid use cases I want to highlight. One is simply just having a single pane of glass. So what I mean by that is NDB, it's a software stack, and it can run in the cloud. It can also run on premises, and it can manage databases that are hosted both in the cloud and on premises. And what that means is you can then say, pick the cloud where you want to spin up your database, and then all the automations, all the standards you defined in NDB, they work the exact same way. That also means you can say, take backups of your database on-prem in the form of snapshots and log backup captures, and you can recreate those databases as a clone the database up in the cloud. And so you can support really interesting use cases, such as maybe your production environment is on premises, but then you're making periodic captures of that database and then refreshing that as a cloned database for development and testing up in the cloud, where you have the ability to dynamically scale and then tear it down when you're not using it. So you have a lot more flexibility to control your pricing. Um, all of the functionality that we provide in NDB, such as in allowing you to define all of your database standards through profiles, standard t-shirt sizes, OS database versions, things like that. That same behavior works in the cloud. And in addition to that, when you do provision with NDB, we take care of automatically applying all the best practices in terms of disk layouts and OS tuning and database tuning so that you get really great performance right out of the box. And so that same behavior applies to on-premises infrastructure that you deploy your databases onto, as well as to the NC2 infrastructure in the public cloud. I'm gonna spend a minute and just talk about HA and DR because I think that's always an interesting one, and there may be some questions around that, or maybe licensing and whatnot. So I'll be happy to take those, but maybe if you can reserve those questions, just add it as Q&A to the webinar. If you can, and then David can try to respond offline. Or David, if you feel like there's something really important that comes in while I'm presenting, feel free to interrupt me. If not, you can save it to the end and we can answer your questions then. So
Okay.
when we, yeah, thank you. So when we talk about HA and the DR, NDB provides HA and DR databases. Well, let me start by saying this. Every Nutanix cluster is highly available. A single cluster could easily achieve 5+9s of availability. That's 3 nodes with distinct compute, RAM, and storage that are grouped together as a distributed cluster, either NC2 cluster or maybe on premises as an NCI cluster. And that's a highly available cluster that can run VMs. And even without any database technology for HA, a physical server in that cluster goes down, the VM automatically restarts with no data loss somewhere else within a matter of seconds. So that's obviously crash resistant, but for many customers, just simply having a singleton VM, being able to restart somewhere else, is a pretty nice experience compared to what they get with, say, like a native cloud experience, where you lose that instance in the cloud and you've lost whatever's attached to that instance. And so this is a different model because it's using our HCI stack, which has been proven by tens of thousands of customers with the exact same experience in the cloud. But with NDB, you can go beyond that. Obviously, transaction consistency is important. Being able to absolutely minimize the RTO and be able to recover as quickly as possible is really critical for databases because they're supporting so many applications. And so let's talk about a couple of database engines in particular. I just wanted to highlight how we could support high availability and disaster recovery needs in the cloud with Oracle and SQL Server, Postgres, and MongoDB. What I've shown you here is a little bit of an eye chart, but really what it's trying to highlight is that you can provision Oracle, CHA, or a rack environment on top of NC2 in the public cloud. You need to take care, you need to bring your own licensing, but it's physical infrastructure, so you just license the cores just as you would on premises, and you basically license it the same way you would with an on-premises cluster. You can deploy rack. NDB can deploy rack automatically in the public cloud, and NDB can automatically set up an Oracle standby. If you want a DR, you can define a disaster recovery policy in NDB and say, I need a standby, or maybe I need a cascaded architecture, and NDB will automatically set up that stack for you and then manage that DR stack for you. So it's a full end-to-end solution with Oracle where you can get highly available in the cloud, and then you can even span multiple regions if you need Oracle build fill over to a different region. For SQL Server, we achieve much of the same thing with always-on availability groups. So you can create availability groups and you can choose where each replica sits. They could be in the same NC2 cluster, or they could be in different NC2 clusters. And of course, you need to think about latency between regions. So you wouldn't want to do synchronous from East Coast Amazon to West Coast Amazon, but you could certainly do asynchronous, or either in that region or in a different region. We do the same thing with Postgres, and we do the same thing with MongoDB. So it's a really nice solution where you get a high level of automation for your databases. At the same time, you retain control. With NDB, you don't lose, it's not a fully managed service like you would see with a hyperscaler. So you retain full OS access to your VMs. If you need to, you can inject your own custom software and the gold images that are used as part of the initial build process to build out that environment. So it gives you a lot of flexibility to install your own auditing tools and compliance, security tools, things like that, that you wouldn't otherwise have access to with more of a black box managed service environment in the public cloud. I would just call out that when doing these types of deployments in the cloud, it's important to recognize that we need to work with Nutanix networking stack, which is called Flow, and Nutanix provides a full virtual networking stack with all the microsegmentation, east-west firewalling, all that type of jazz. It also provides a full overlay stack with its own virtual private networks. And so to use this type of technology, you do need to use Nutanix Flow VPCs, overlay VPCs, for hosting in DB in the cloud, as well as all of the databases and their replicas or standbys. So you can't use the cloud native VPCs. The other thing I would mention is that we don't want any natting between those components. So, obviously, if you are interested in building out this type of architecture, you would work with your account team, and we can bring in the right experts to help you out from a solution design and implementation. But we want to make sure that we have clear IP routing and the ability to communicate between those systems. I will just highlight one specific example that goes a little bit further. So this is a MongoDB replica set architecture that actually spans on-premises and cloud. And we're seeing more and more of that from conversations with our customers, these types of hybrid scenarios where it's not just about HA across regions or DR across regions within a cloud provider, but maybe they have part of their database on premises and part of their database in the cloud, and they're actually trying to bridge the gap. And so this is just one example. This is an area where we are working closely with our customers to support other use cases for other database engines. And that's a journey for us, but we're very actively working to support customers that have that type of hybrid requirement. If you do have the type of hybrid requirement, please let us know, and we'll be happy to work with you to figure out the right solution for you. But the idea here in this particular example, this customer had two regions on premises. They actually had two data centers per region on premises. But for business reasons, they wanted five node MongoDB replica sets. And in many of their discussions with MongoDB, they concluded that to do that and to provide region level resiliency, meaning a failure domain of an entire region, they needed to have a third region. And they only had two physical regions with their data centers. They didn't have a third region. And so cloud became a very, very interesting consideration. And so what we did is we worked with them to set up an NC2 cluster in a different region in Azure, which they had a corporate account with, and that became the third region. And so MongoDB, primarily hosted on premises for on-premises workloads, now had this had a fifth replica sitting up on that NC2 cluster in the cloud that could help. That could be a disaster recovery destination if needed, and could provide them with the ability to fully support that five node MongoDB replica set. And at the same time, if they did happen to lose their on-premises regions, they could actually recover to the public cloud if they needed to. So that's just an example of hybrid cloud. Obviously, the networking, the details are always in the networking. So if you do have this type of thing, please reach out to us and we can work with you to figure out how best to accomplish that. This is an example using Nutanix networking stack, but we do have examples of other customers that have used their own networking stack, like from Cisco or other networking solutions. So it just really kind of depends on what you have. But obviously, using this end-to-end stack from Nutanix makes it a lot easier from a supportability perspective. So that's something to consider. David, any questions so far?
Nothing I'm seeing yet. But
Okay.
yeah, I would say too, Jeremy, this was something, we did with Nutanix. We didn't have NDB when I was a customer, but we had an always on availability group, and we had one of our nodes up in in an Azure public cloud, just literally as the ultimate fail-safe DR. So if something catastrophic happened, we still had the ability to at least have our data up in the cloud for our SQL cluster, to come back online. Maybe not at the same capacity, but at least would still be able to provide access to that data.
Yeah, and I think of it that way too. I mean, there's just a lot of examples where customers just simply don't have another region. They have one data center, maybe they have two, but they don't have three, they don't have five. And so, and how many people are continuing to build out new data centers? It's so it's kind of there's actually a lot of opportunity to leverage the cloud to provide more resiliency. And even if you don't really want to permanently run your workloads in the cloud, at least gives you that level of resiliency. And because the underlying stack works the same, you don't have to change how you do things. You don't have to learn new skills about that cloud provider to do it. Okay, well then I think now is a great time to have to see a demo. So I'm gonna. Oh, I'm sorry, I jumped the gun. I have one more slide I want to talk about before we do that. I wanted to just kind of highlight some of the key sort of infrastructure requirements, and these are very high level. So obviously, like I said, the devil's in the details, especially when it comes to networking. But high level, there's three key things you need to think about if you want to run NDB on the public cloud. One is that the database is run on top of Nutanix cloud clusters, which you can take your existing Nutanix licensing and apply. You can also buy licensing through the appropriate cloud hyperscalers marketplace. Um, a cloud cluster, just like on premises, requires three distinct servers, which we refer to as nodes, that have compute, RAM, and storage that are localized in that server, and that creates a distributed fabric for compute and for storage, highly available storage. So it requires a minimum of three bare metal instances in the cloud for each NC2 cluster. We need flow VPCs to be used as the networking for that cluster and for databases running in that cluster, as well as connectivity to other clusters if you're trying to do any kind of always on or something like that across cluster boundaries. And the other thing I would highlight is that NDB does require Prism Central, and we want to have one per region to align with our best practices. So with that, now let's go ahead and see a demo. So I'm going to go and stop sharing, and David, and I'll turn it over to you.
Thanks a lot. Yeah, so I pre-recorded this demo just to make sure we didn't have any issues, but it's going to start out by showing you the networking inside of Prism Central in an instance running in AWS. So both the demo and the Nutanix clusters are all running in AWS. So off we go.
We begin in Prism Central, our unified management plane for Nutanix, which in this demo is running in AWS. From the side menu, we'll navigate to Network and Security, then Virtual Private Clouds, to view our environment's connectivity. Here, you'll see the Transit VPC alongside the dedicated NDB VPC. This setup includes externally routable subnets, ensuring seamless communication across the hybrid cloud. Opening the Subnets section reveals the NDB overlay subnets created during initial setup. While we are using overlays here, NDB also supports standard VLANs if they are configured on your registered Nutanix clusters. Now, let's switch to the Nutanix Database Service interface. Under Settings and Nutanix Clusters, you can see our two registered clusters, both currently running on bare metal AWS instances. A key advantage here is scalability. Once NDB is deployed, you can enable multi-cluster to manage databases running on Nutanix, whether they are in your data center, co-location, or the cloud. Next, let's look at our profiles, which serve as the blueprints for our deployment. In Software Profiles, we have created a profile for SQL Server 2022. Notice it is already replicated to both clusters. If we added a third cluster, we would simply add the cluster by choosing the Actions dropdown, then Update. Also, if you had dedicated clusters for, say, PostgreSQL and SQL Server, you could choose to only replicate those software profiles to the clusters that are designated for them. In Network Profiles, I've created a specific profile for the SQL availability group. It spans the overlay subnets of both Nutanix clusters. I also set up a Windows domain profile, as that is required for provisioning a SQL AG. With the foundation laid, let's provision the AG. We'll go to Databases, then Sources, and select SQL Server Availability Database. On the Windows cluster screen, we will create a new cluster and name it. We are going to use both Nutanix clusters that are available on this cluster. Then we will select our network and Windows domain profiles that we set up before and leave the quorum witness as a disk. Also, you can enable NDB to use WinRM over HTTPS. With our selections made, let's head to the next screen. On the Database VM screen, we will select our SQL 22 software profile. NDB will only show software profiles that are available on all of the clusters you selected on the previous screen. We will also select our computer profile, which sets the number of CPUs and memory for the cluster, and then the administrator password. From here, I'm going to add a server and set my database parameter profile, which configures the SQL database engine's parameters. I'm going to rename the VMs for my database server. Then set it up so there are 2 replicas in my primary data center and 1 in the other. You can add up to 9 replicas, which is the max for a SQL AG. You can also grant access to a Windows domain account or group as an administrator for the SQL server on this screen. With everything set as we want, we will move on. In the next step of the workflow, we can change the AG group name, the listener name, and the port. You can also set the settings for the servers that are part of the cluster. We are going to leave them as the default, but in addition to yes or no, under the readable secondary, you can choose read intent only, which is perfect for offloading reporting workloads. Under backup preference, you can select where you want NDB to take snapshots of the database and logs. This feature allows the option of taking snapshots from a non-primary server. If you change your mind on this setting, you can use SQL Server Management Studio to change the backup preference for the availability group after it's provisioned. With that set, let's head to the next screen and set up our database options. We are going to set our database group name and the names of our databases. You can change the initial size of your database. You will then select your database parameter profile, where you can set options such as the minimum and maximum memory SQL Server can use. Once we have our database options set, we will move on to the Time Machine screen. On the Time Machine screen, we can select our SLA for our full database snapshots and log backups. It will automatically select the clusters that are part of the AG group. Watch what happens when I switch from a bronze policy to the gold. The adjustments to the schedule to include frequent log backups, providing a much tighter recovery point objective. Once we are happy with the options, we can click Next. On the last screen, we will select our maintenance window for patching. You can see the settings of each maintenance window by hovering over the information icon. I am going to select Production. From here, I would select Provision. However, to save time, I've already provisioned an AG cluster in advance. Let's head over to the Operations section and look at the completed provisioning operation. Once we select the operation, we can see all the steps NDB took to provision the AG database, including the time spent on each step. NDB doesn't just install SQL, it applies all Nutanix and Microsoft best practices. When provisioning is complete, the database is joined to the domain and ready for use. Let's head to the database screen to view its details. On the Details screen, you can see all the information about this database, including what servers are part of the availability group. You could add another database to the availability group and see the profiles used when it was provisioned. In the Time Machine section, let's click the Time Machine name to see its details. The highlighted dates on the calendar show that there are snapshots taken on that day. If we click Data Access Management at the top, this shows where our snapshots are being replicated. If you were to add another Nutanix cluster to Nutanix and wanted to replicate snapshots to that cluster, you can click on the table, then add your cluster and select an SLA and click Add. You can replicate snapshots to any Nutanix cluster that has been registered with NDB.
Cool. So that was a quick demo of multi-cluster provisioned SQL in AWS. You can do a lot more with that. Like I said, you can have more nodes to that. You can, if you added another cluster in the same region, you could potentially replicate it over there. So it gives you a lot of freedom. And the cool thing is, I did mention you really only need one NDB interface. So this interface did not have to be running in AWS. It could have been running on-prem. And if I had connection, if I had connection to that cluster in AWS, I could connect it to NDB and still manage it with the same NDB I'm using on-prem. I don't necessarily have to have a separate NDB. However, you can have a separate NDB. I don't think we license the appliances. We just license the use.
Yeah, that's right. Yeah, thank you very much for that, David. I think that was fantastic, man. I'm really before we move over to Q&A, I just had one more slide I wanted to share to everybody. David, can you see this QR code?
I can.
Okay, so what you all saw was an example of a highly available HA database spread across multiple cluster infrastructure in AWS. This is a QR code to another video that David had created a little bit, a little ways back, not too old, and that actually shows an example of how this whole thing would work in Azure. So if you're an Azure customer and you want to see how that would work in Azure, you can scan that QR code and go take a look at the YouTube video. It's a almost identical experience, and that's intentional. Like the fact is, whether you're at Azure, AWS, or on-prem, your experience really should be the same. There's some nuanced differences in terms of how the networking works, VPCs versus VLANs and things like that. But once you get that base setup done with the assistance of our engineers and experts, it becomes okay, I can manage this stuff the same way across these clouds. And that gives you a lot of flexibility. So I'll just give everybody a minute to scan that if they'd like to.
I think that's one of the great strengths about NDB. Even if I was to turn around and do a Postgres or even a Mongo cluster deployment, sure there's some sections that are different, but it still kind of feels the same way. You set your cluster name, you set your database name, you set your time machine, and it just goes. I didn't know anything about Mongo, but I can provision a Mongo sharded cluster if I wanted to because the interface makes it so easy to do. Like if you understand databases, you can pretty much provision any database with NDB.
Yeah, I think that's a great point, David. And the fact of the matter is that it's not just the GUI that makes it easy for the admins to kind of set this stuff up and do it. It's also really easy for a developer to call an API and say, "Give me a database with the API." Right. So it's both targeting. It's both a platform that's making it easier for DBAs and database platform engineers to say offer a standard set of database services to their business, but it's also easy for the business to consume it. Okay, well, I think anybody that wanted to capture that QR code has probably already done so. So we can just move to Q&A. I'm going to stop the screen sharing and we'll just open up to any Q&A. Like I said, there is the ability to post Q&A. I don't see any questions that were raised. If you want to, you're welcome to just raise your hand and we can take your call directly. You could also just post into the chat if you have any questions about anything that you saw. One, by the way, while we're waiting, one of the things that is a frequent question is, okay, well, how does licensing work with NC2? And all of Nutanix licensing is portable. So you buy to your normal, partner. You buy, and we're all channel based selling. So you buy through your standard sort of technology partner, Nutanix licenses. Those licenses can be applied to on-premises infrastructure, or it can be equally applied to your infrastructure in the cloud. You need to pay Amazon or Microsoft for that bare metal hardware versus paying Dell or Lenovo or HP for your hardware on premises. But the concept is the same. Basically, it's just a cloud hypervisor's hardware. Otherwise, and minor differences in the networking, like I mentioned, but otherwise it behaves the same way. So you can buy the licenses that way. If you haven't purchased the license that way and you have like a cloud commit in the cloud, you can obviously buy Nutanix licensing, including NDB, directly from the Nutanix software vendor spot in Amazon and Azure's marketplaces. So that's always an option if you haven't already bought that way. And once you have that license, and you can apply it to the infrastructure, and then you can use it. Just like on premises, we don't provide the Oracle licenses or the SQL Server licenses. You need to bring your own OS and SQL and database licensing bits. So you have to bring your own licensing, and you need to work with your appropriate vendors to make sure that you've licensed the infrastructure. The difference is this is physical infrastructure. So a bare metal instance in the cloud is a physical server with a set number of physical cores. So you can license by core just like you would on premises, and you can contain your licensing expenses by doing so.
And I mentioned you can have multiple NDB appliances with your NDB license. Do we have guidance? Do we do it like Prism Central that if you have multi-region, you should have an NDB in each region? You shouldn't like manage NDB shouldn't be managing databases in Europe if you have it in US and Europe. Is that kind of the idea as well?
Yeah, it depends on the size and scale. So we do see examples of customers that have different deployments of NDB. We also see examples of customers where they use one NDB that spans multiple regions and potentially multiple clouds. So very much, but that I think that's where if you are wanting to do that type of topology that spans clouds or at least on premises to the cloud, please do reach out to us. We can, obviously we can work with your team to figure out what makes the most sense from a solutioning perspective. Okay. Well, I don't see any other questions or hands raised, and so I suppose we can wrap up this call if there's nobody else from that joined us that has any questions about it. But I do want to thank everybody for joining. Hopefully, this was useful to you. David will post a recording of this session online on YouTube, so you can reference that or share that with your teammates if you'd like to.
Thanks a lot, everyone.
Okay. Thank you. Thanks, David.
Take care.